So we are used to thinking of oxygen as being a limiting factor for exercise, for muscle activity. Actually, temperature is also a very important limiting factor. Humans are mammals, and mammals are known for regulating their body temperature at a fairly precise level. And this is probably one of the best examples of homeostasis. Homeostasis is the magical word in physiology. It refers to maintaining some aspect of the body, some function of the body, at a fairly constant level. So temperature is one of those functions. And we live on the edge. So we regulate our body temperatures around 98.6. If you're used to thinking in centigrade, it's 37. And it only varies a few tenths of a degree across the duration of a day. And that's in spite of the fact that we experience huge ranges of ambient temperature. In the morning, this morning here, it was in the mid-40s Fahrenheit, and by late afternoon, it might be in the 80s. So that's a huge range of temperatures, and within that, we maintain our body temperatures within a few tenths of a degree. We, at rest, our metabolism is about 100 watts. Now, you can think about a 100-watt light bulb and how much heat that produces. So that's how much heat we produce just sitting. That heat is being produced in the core of our body and distributed around the body. Now, if you get active, you may increase your heat production by 4 or 5-fold. And that means 400, 500 watts. That's a huge amount of heat. We're able to regulate our body temperature because we have adaptations for heat conservation, heat production, and heat loss. So heat production, obviously metabolism. Heat loss, sweating and sending blood to the surface of our skin to dissipate heat to the environment. Now, what controls that? What controls that is a thermostat in the brain. It's in a part of the brain called the hypothalamus. If you roll your tongue all the way back and touch the roof of your mouth, the hypothalamus is just a little bit above that. And that thermostat is itself temperature sensitive. So if body temperature goes up, the warmer blood is flowing through that part of the brain and it turns on the heat loss mechanisms. If body temperature goes down, the blood flowing through the brain is cooler and that turns on the heat conservation mechanisms. And with fairly intense exercise, it's not unusual for body temperature to go up to about 100, 102 degrees, similar to a fever. But with more intense exercise or longer duration exercise, core temperature can go up to 104, 105 degrees, and that is the danger zone. You begin to get to 104, 105 degrees, cognition is affected, and you begin to see failure of physiological systems.